Hi, this is chapter 6, and it's a quick hit on the formation of wind, which is a horizontal difference in air pressure, as opposed to convection, which is a vertical difference in air pressure. Remember, this is a review. If you need to go over this again, look at the beginning of chapter 6. But in regard to wind and horizontal differences, we want to talk about the fact that we can have two columns of air in a city that go up about 1 kilometer, and we could cool the first column of air, and it would become more dense, and it would become shorter and a little bit more stocky with density. And we could warm the second column of air that might go up to about 3 kilometers high, and that would become less dense because you have the same amount of molecules over a greater area and over a greater volume. I think you know about that. What I wanted to point out to you was that we know that atmospheric pressure is the amount of pressure pushing down on you that is above you. So that warm air column has higher pressure aloft. Let's go back and look at this. If we looked at the 1 kilometer line, there was still pressure above the 1 kilometer line. There was higher pressure above the 1 kilometer line. If we looked at the colder column and we were at the 1 kilometer line, there's no pressure. It's very low pressure. Remember, this is a theory. There's very low pressure at the 1 kilometer line in the column that was cooled, in the air mass that was cooled. So what I want to point out to you is that, sorry about that, that warm air aloft is associated with high atmospheric pressure aloft. Okay, so warm air aloft is normally associated with high atmospheric pressure aloft. And cold air aloft is associated with low atmospheric pressure aloft. I want to go back there again. Low pressure, cold air. This area of warm air has higher pressure aloft. Let's look at it this way. Okay, higher pressure aloft at this area. There's low pressure above this area as well. But you can also establish variations in air pressure both aloft and at the surface by heating and cooling these columns of air. You know that pressure seeks equilibrium. So if you have higher pressure in this column, it's going to migrate toward the lower pressure area. You're going to move from high pressure to low pressure. You're going to get some molecules out of this column that move over to the colder column. When that happens, the pressure is reduced at the surface. Look at this, surface pressure falls. Because guess what? At the surface, you've got less molecules above you. You have less molecules above you, lower pressure above you than you had before. And correspondingly, column 1 got a whole lot of air molecules in from column 2. It has more molecules pressing down. So when you're at the surface pressure rises. Guess what? We seek equilibrium here at the surface as well. Now you've started something that started aloft from high pressure to low pressure, and then continued to surface from high pressure to low pressure. You're pushing these molecules back into this column. The pressure gets higher aloft, and it keeps this circle going. Please understand this circle. If you want to stop here and take a look and think about it, that would be great, because you need to understand that it's a fundamental way that our atmosphere works. The next thing you need to understand is that surface high pressure, right here, is associated with sinking air with a lot of density. Remember our lab where we had Denver on the one side that showed really nice, warm, dry weather. Remember the leeward side of the Hawaiian island where the weather was much warmer and drier. Keep in mind that surface high pressure is associated with sinking air and good weather. And conversely, that surface low pressure is associated with rising air. Rising air that is really reducing its density. Remember, we were on the lab and we looked at rising air along the mountainside associated with stormy weather, associated with ski resorts, also associated with the rainforests on the windward side of the Hawaiian Islands. Surface low pressure is associated with rising air and stormy weather and the windward side. Go back over this. You will need it for the future. I hope this helps you out. Take care.